thank you all for showing up for my session exploring the world of parallelism with PowerShell. I hope you are interested in this topic because now we want to scratch the surface and we'll have a look about several methods how to make use of parallelism in PowerShell. Before we start, I have to say thank you to our sponsors because without them, this whole event wouldn't even be possible, and also without a view, neither. So thank you for showing up. When it comes to parallelism, we could make some room for those people in front here. When it comes to parallelism, it could be kind of hard because we aim for good code. We aim for fast code. But most of the time, we aren't aware of that we only send in some lonely worker into the hole with a shovel. So we should make use of all of our cores and do things in parallel. Done. A little bit about me. My name is Christian Ritter. I'm a senior system engineer working at Kerncom in Germany. I'm a father of 2 beautiful children. I'm a husband. If it's a hobby, I guess. I'm a passionate billiard player, not a good one. And I'm also the hobby chef or the only cook at home. So yeah, I'm a board game geek. If any of those interests fits you, head out to me. Otherwise, we talk PowerShell. That's also fine. When it comes to coding, I make mistakes. I make mistakes all the time. There's not even a single day without any red line on my screen. I like to make code go fast. That's the reason why I choose the topic parallelism. And I also like to make it stable and spread the word about it. So that's what I am. A little disclaimer. If I'm the smartest person in this room, really filled for records, if I'm the smartest person in this room, I'm in the wrong room. But what I mean with that sentence, I like to learn. Because sometimes you have something in addition or a question that could spin up another discussion. Maybe we have shifted to the end of session or to the hallway, but we can learn from each other. And that's the reason, if you have something, please don't be shy, raise your hands. Okay, question time. Which methods do you know how to parallelize in PowerShell? Just shout. Jobs. Okay, good one. Run spaces, yeah. For each object parallel, I guess. Okay. Thread jobs, yeah. Invoke command, yeah, kind of also. Okay. We'll keep it as this because I've prepared only this one. So, so there's no live coding today. Live execution, of course, but no live coding. So we will talk about jobs for each object parallel, run space factories, RS jobs, and threads. Afterwards, some bit of safety if you have time for this. Okay. What are jobs? With jobs we can run asynchronously. We can manage those jobs. We can monitor those jobs. They're easy commandlets. They're easy to use, and there are different types of. And we probably will see them also later after the first code bit. As talking code bit, let's head into Visual Studio Code. And now you should see better because I'm standing here. No, that's not the one I aim for. There we go. If it's readable, is this readable for all of you? No, I have to increase. That's perfect. Thank you. But there's also a screen right there. So, oh gosh, what I'm doing? Why it's not increasing? Yeah, I don't know why. Because it should. Oh, I know. 1 second. I'm sorry about that. With the German keyboard for a German device, it should probably be better. Yeah, there we go. Okay. As talking job, when we want to create a job, it's kind of easy because we make use of the command start job. We pass in the script block. There's a function in the max value quite fast. I said, yeah, I can't change it right now. So I can try to be louder. Maximum number out of several numbers. So you can also make use of it later if you like to just copy my code. But in this case, we want to start our job, assign it to a variable job, and then we can inspect our job. So our job has a name, as I was given it here. I'm very good at naming things. There's a type of a job. In this case, it's a background job. We have a state where we can detect if the job is still running or if it was failed, or if in this case it was completed, it has some more data, and where did it run. Because also we can make use of remoting jobs, for sure. Now, but there's even more, so we have a look about the members of this job. There are several other properties and methods. Like we could stop our job over a .NET method, for example. We can make use of several streams. It doesn't have a name. Job child, well, outing child job object. And before, we are just a PS remoting object. So now we have, and we want to retrieve the result. So how can we do this? Make use of the command, make use of a pipeline, the command wait job until it's finished. Now we know it's finished because we had log already. Afterwards, we can receive those jobs and get the result back. In this case, it was the highest number of all those randomly generated numbers and was quite a large number. I guess I have to also prepare the shortcut for well as that. So, okay, now we can see some. Make a little cleanup, so we have to remove our job. Because now, get job, for example, I should see all the job that in the current session was running. In this case, 1. After removing the job, it's empty out. Get empty. Don't say same thing and type at the same moment. It's probably a bad idea. So, but now our jobs are cleaned or deleted. So, but what happens inside of this script block? For example, or another script block. Let's make it something up with the get child item command. Let's have a look at the file about the members, which properties and methods and script properties we have here. We have a lot of them. There's also some method for move or open read text and so on. Exact same command inside of the start job command in the script block. Wait for the job and receive the job. Some of the methods and also the properties are missing. Some of them have changed. For example, the base name of the object is now a node property. Before it was a script property, which was doing some magic with the string to receive those base names. And the type, in this case, file info object, compared with the other one, file info object. So when you pass something via a script block to a job, please keep in mind the object changed a bit. So if you rely on properties or methods, please be aware of that. Okay. Now we could simplify the parsing via the pipeline, because the receive job command has also an auto remove job parameter and a wait parameter, which means we don't have to parse, it's all included. So we can streamline the whole process of creating, receiving, clearing to just a simple command after creating those jobs. So now I want to show you something about the streams that we could receive from a job. So I've created a little function. I don't want to go deeply into it, just that you know, because I also say something about monitoring. Then I defined several script blocks to just writing out to the info stream, start sleeping, not randomly, differently, writing, sleeping, writing, thrown errors, and giving back a result. Let's see how this goes with my function. I just have to make sure I have to be a bit more space, I guess, just for this, because it's zoomed in so much. And now jobs are running. I'm asking for the information stream. Ask for the information stream. We write a line. So I think it's kind of nice. Look at something. So then we see, okay, which job was failed. We see the output and the run duration. Because some of the properties, one of the properties is PS begin time, which says the exact moment in time when this job was started. And there's a PS end time. So with simple math, I can say, okay, what was the run duration for my script block? And I could see, okay, what was the output and also what is the error. And if you haven't been to Emerald's session yesterday, you really should have been there. Otherwise, please make sure to watch recordings because he did an amazing session on how to throw errors. So, and now let's inspect those streams a little bit deeper. So I prepared a little job here. Let's call it role job. And now I can make use of the child jobs information stream, the warning stream, also the output stream, for example. And now we should never gonna give you up. So, and yeah, sorry for Rickroll. But some commands already has a parameter as job. And to see which commands are capable of this parameter, we just can say, okay, get command, parameter name as job. And on PowerShell 7, basically with the default set, this is not much. But at least we have 2. And I think on PowerShell 5.1, it's something about 12 commands, probably. If you have some time at the end, I could show you. Okay, and that's everything I have for jobs right now. So we head back to my slides. And I got up walking because now we want to talk about for each object parallel, which was introduced in 7.x. And they took our jobs because now we just have to say, okay, do something parallel for each loop. So it's good when you have access to PowerShell 7.x. This would be pretty good to use this. And there we have parallel execution. We have a performance increase, and also we have some capabilities of throttle limits, for example. So we can say how many threads of my CPU are really dedicated to do this at the same time. I will show you why I did this for saying same time. And they use run spaces internally to archive this parallelism. And now, with that said, we can head to the demos. Okay, so to do something in parallel in PowerShell 7.x, it's really basic, simple. We just have to say for each object parallel, then I pass in 1 to 10 over the pipeline, and then I can say, okay, do 5 at a time. So it would be 2 that run. So now, if we make a look at the execution time, because now I do something 4 times, wait for exactly 1 second, and for a limit of 4, so all of those jobs should kick in at the same time, and should be take only 1 second in total. But if we do this, we see, oh, that's a little bit more seconds and milliseconds I would have been expected. And that's the thing I say about pipeline. It can be somewhat slow, but it don't has to be slow. Yeah, it has to be because it's necessary. Sorry, I totally missed this. But it increases. So when I go over my thread limit of my CPUs and go up to 80, for example, and also do this 80 times, you will see, okay, the number should increase. And in fact, it did. Now, just the 1 second operation took 3 seconds and some milliseconds. And if I go to 1000, because it was 1024 times, it get even worse. So, why I say because they say they took our jobs, but they also brought it back. Because we can pass the object or the iteration as objects. So, in this case, let's figure this out. And now we have back our jobs. And this time we have PS task jobs. Before it was PS remoting jobs. Now it's with the actual object a little bit. But we also have some child jobs, which you can have a look at. And there we see all of our jobs that was executed in this scenario. So, but the thing is, like I said, do they really run in parallel? Because when I say now, have a look at the begin time, you should see, if I make a little bit increase in size, you could see at 49 seconds was starting the first 4 off, and at 50 seconds, the next iteration, because I had said there's a throttle limit of 4. So that makes sense. And it looks like it's exactly the same second, so it should be real parallelism. Then when we have a look at the milliseconds instead, you can say, we see that they kicked off at another millisecond. So at some point they were really parallel processing, but they didn't start at the exact same time, didn't end at the exact same time, as saying they didn't end at the exact same time. When we now have a look at the execution time for each of those jobs, you also can see some. Right now, this one is not a second anymore. I'm wondering why, but they invented some kind of time machine, I don't know. Or it says with PowerShell, yeah, even faster. So, and we can see, okay, the largest one was about 1 second and 140 milliseconds-ish. So, that's everything I have for each object parallel right now. You can make use of jobs of it, and you see, okay, what is really parallelism behind it. So, but if you're a poor soul, and I saw in the keynote, there are many of those. In 5.1, we haven't the capabilities of for each object parallel, but we have run spaces. So, we have run space factories. So, with run space factories, you can aim for the same goal like with for each object parallel. We have the execution isolated. It's runs on separate threads, each run space, and it's independent for the operation itself. With that said, let's head directly back to code. Because to create those, it's a little bit, you have to be aware how to create this. Because at first you have to create the run space itself. So you spin up a PowerShell object, make use of the create method. Then you have to add the script via this method .add script. Then my pretty function I will paste in again. And then I can say I want to start the invoke so that it starts to run. Let's first create those. Okay. And now, when I say begin invoke and assign it to a variable, I receive some kind of async object. And we see also the state is completed. Yay, it's completed. Otherwise, I have to wait until it's completed. I can do it with the do until loop, for example, and just wait for it. And now we want to retrieve those results because where is it? So we have to make use of the end invoke method and pass in the async object. Therefore, we will receive the result. And can I have a look at the result? Okay, and this time was under 1000. And afterwards, we have to dispose this run space to free things up. And we are good to go. But I said, okay, this was only one run space. What's the difference between a job and those run space? I have to make a run space factory to pass in multiple run spaces, or a run space pool, sorry for that. And then the parentheses, I have to define how many in total I allowed to run at the same time. So this is kind of the throttle limit. What's the minimum number for this? And to open the pool so I can join in, some fun in the water. Yeah, please. Is this somehow bound with CPUs? No, because when you go over the limit of the CPUs or the threads of the CPUs, it begins to run in concurrent, not in parallel anymore. So think back of the time. The question was, are these numbers any kind bound to the CPUs or to the CPU threads? No, they aren't. If you go over the limit of your current threads itself, it starts to begin to do things concurrently, which means if you think back of the time where your CPU was only one in your computer, you didn't have to wait while you wait for opening a mail and the music player stops. It wasn't the case because it was handled on the CPU concurrently, so it seems in parallel, and it's the exact same thing for that. But a computer is pretty good for aiming for a flawless run, so you shouldn't see such much of a difference. Okay, and afterwards we create our run space once again, like we already know. And if I would able to use my mouse proper, I could mark everything I need. So, then I have to assign the run space pool to my run space to say, okay, which is for what is dedicated, because I could have many run space pools, for example. Wait, yeah. And then I just have to invoke once again the run space. I have to wait for, but it was not a big deal of operation, so I don't have to wait for right now. And then I say again and invoke, dispose, dispose. And I have to close the pool. Okay. But now it's only one run space inside of my pool, isn't it? I want to have multiple. So, I want to have multiple, so I could just open the pool once again and iterate through 1 to 10, for example, if I have 10 jobs running with a for a limit of 5. But in this case, I have to be aware of one situation. When I want to receive those, I have to spin up some kind of an object, like here PSCustom object, where I have to put in the state, so which was also async object earlier before, and I have to keep the run space itself as an instance for retrieving those. That will be hopefully a little bit more clear in a second. Just let me run this and assign to variable jobs. Oh, I probably forget to highlight this as well. So, and then when you have wait for multiple jobs, make it be a while loop. So you can ask for is completed, if it contains false, please sleep, otherwise the job is finished. And now to receive those results, I can iterate through all of my jobs. I assign the result over my object itself that have been created with .instance, .end invoke, and then I pass in the iteration marker with the state property. Then I can dispose it and return the result and it can be result. Okay. And then I have to close the run space pool. And we should finish. And now in the results, we can see, okay, there should be about 10 numbers.
Is there actually any need for that sleep on the lines above? Because
yeah, I'd like to say the sleep, if you do just a loop without any kind of sleep, the CPU...
Yeah, but you don't do loop. Yeah. If you don't do that line and then go straight to line 94, that's going to block.
Yeah, sure. Yeah. Yeah, that's the point. The jobs have to be finished until I can retrieve those when I iterate through.
Yeah, but you don't need to wait for it to complete.
No, I could receive. I don't have to wait for. Yeah.
Because you wouldn't be hitting the CPU.
Correctly. That's a good addition. You don't have to wait for all of them to complete it to receive those objects. You could do it while it's running. But I like to say, yeah, when I do this, I just wanted to wait until all are done. But perfectly addition. Thank you, Guy. With that state to run space, one question to the audience. Looks this kind of simple to you if you haven't done it before already? Please raise your hands. You think it's kind of simple? Okay, thank you. But for all the others, and also you, I could show you some ways that are even more simpler. Because we now want to talk about the S jobs, because many people hated to do this by hand. So what I did instead, there was someone, I don't know who did this, but there's a module called IS jobs, which you can leverage off because it's easy of use and there's the same functionality for this. To make it short, we had to demo. AS jobs. So the module is called posh AS jobs. So we have to import the module first. And then we just have to find the script block. And now we can iterate through 10 times and start our S job with a script block, an argument list as well, and also a name. So in this case, I just want to put out which item number was processed. I could do this right here. You see, okay, a job is running, so there's kind of an output. If you don't like it, just pipe it to null. And with get AS jobs, we said, okay, that state is completed. We received those. Now we want to receive those. We also can make use now of wait if it hasn't completed already. And afterwards, just with receive AS job, like we know already before, we can receive those. And also in results, you see, okay, processed item 1 to 10 on several threads. And now we can also remove it like that. Okay, there are the results. Anyhow, so, and we also can make use of throttle limits. So, like run spaces, it's just imagine this as a wrapper for the run spaces itself we had to create earlier before. Now the question again, if you're stuck to 5.1 and you know now about run spaces, would you do the run spaces by hand like we did before, or would you make use of such a module like AS jobs? Please just raise the hands. Single hands. So many lucky souls using PowerShell 7.1 or 7.x. Sorry. Okay, that's fine. It's fair enough. Let's head to threading. With thread jobs, you don't have separated processes, so everything runs on the same process, which could be kind of a little bit faster, but the major process while you're executing could blow up, and if it goes terribly wrong, you lost your current session, and it could be a bad idea. So if you have small jobs that need processed really fast, you can make use of thread jobs. Thread jobs are integrated in the PowerShell 7.x, I think so. Correct if I'm wrong, me please. But you can also install them on PowerShell 5.1. So with that said, head to the demo. Threads. Okay, perfect. So, like once again, random script block for creating random time of sleep, for processing items. And then let's spin up 10 jobs. And with the command start thread job, we can also pass in the script block, the argument list. And then we can also make use now of receive job, wait, and auto remove job. So with our AS jobs, we were dedicated to the commands from the module itself. Now, with thread jobs, we can make use of the receive and wait job like we did before from the job sections in the first time, for the first demo. Thank you. That was what I'm missing. So now you can see it's finished. But we can also see, okay, those were our jobs. And we also have a throttle limit here. But what I noticed about the throttle limit here is you can change it while execution, which means when I do a start thread job, for example, and in the middle of somewhat, I just cancel the operation inside of because it's dedicated to somewhat the CPU usage. I just can cancel all the finished. I could store the rest. I can start another instance, and I can decrease the throttle limit, for example. So I can make pretty use of it. But I also could make use of all the others, to be honest. The time is 1 minute and one topic. Perfectly. I don't want to rush, but I want to show you a little bit about safetiness. Because when you write to an object at the same time in real parallelism, they're starting a condition race, which means there could be some loss of data. It's not usual that this happens, but it can happen, which means if you ever point in parallel to something for a list, for example, please make sure that you use the system collections concurrent dictionary. So maybe I'm able to show you when it fails. Let me try to make some space here. Oh, what's the problem? Yeah, it runs false. Yeah, probably a good idea. Thank you. So I want to talk about safe threadness. Thread safeness. So okay, now I got it perfectly. So for this scenario, I just use a generic dictionary, and I pass in an ID, for example, or random number, and nothing as a string. And hopefully, because sometimes it works not, just like I said, it could mess up. Hopefully it will. I think never ever have a speaker say this phrase. Yeah. I don't think so. It will mess up right now. But wait for another second or so. If you have anything in addition in the meantime, if you have questions right now, we come to our official question part in a second, but yeah, please. Does synchronized list also work for thread safeness, you mean? I think, I'm not sure about it, to be honest. I just know that the concurrent dictionary were created exactly for this use case. But maybe someone else is also smarter than me. Hooray. So, okay, it won't fail. Like I said, sometimes it fails. I also had situations where it was failing. So, like I said, it's not often the case, but when it's the case, make sure it don't fail by using the concurrent dictionary. So, but one example that was always is failing. If you write to a file, for example, let me increase this number a bit because I've tested this several times. Maybe you can see how many times. So, when I write to a file 100 times with just a single string, in parallel with a throttle limit of 10. Oh, that's a safe part. So. Now, we rolling.
Shouldn't you also get Windows 7?
Please?
27?
No. I'll show you in a second why. Yeah, we got some errors. Woo! So, he cannot access the same file at the same second. So we had a race condition, someone was winning, and we could have a look who was winning or not, or who was losing. But in this case, the total count is 98, for example. Yeah? Because from 100 write times to this file, only 98 went through. And to make it safe, we could assign it to a variable in this case, or make use of our newly learned friend, the concurrent dictionary. So, in this case, do it safe. Yeah, please.
Could you also add a mutex to write to the file so that it's getting queued?
That should be possible, yeah. So the question was if I could make use of a mutex to write to this file. Yeah, of course I did, because it was also a purpose in case of parallelism. Yeah, I could so, but for me it wasn't necessary to do this, to be honest. So let's do a count, and we're up to 100. And with this said, even I have to mention Fred Weinman with his PS framework module, because to write into the same file with this module, he also handled this quite well, because he makes sure that all went to the file, because he's also really good at queuing and using run spaces. So if you see him, have a chat with him. Okay, now we come to the Q&A part. Any questions that wasn't answered already? Yeah. You're my new friend. So perfect. How do you pass function to a parallel job? Yeah, that's a neat question because it's also kind of complicated question, to be honest. The thing is, when we go to for each object parallel, I just have to make sure I make some room live coding, and I probably will fail miserably now. So, for example, 1 to 10 for each object parallel. Yeah, thank you for auto-completing. This was not what I expected. So, and then I have some kind of a script block. So, and there we want to make use of our function, for example. So, for example. Yeah, thank you.
Even though you can't start.
So I think one option to do this, I don't want to use parameters right now, is return. We just make use of return. Return. Applause. String would be probably a good idea. Applause. So I'm not sure if I'm missing an E, to be honest. I do.
If it's English.
Yeah, it should be. Thank you. So, okay, one more time. So, because now I have defined a function outside of the scopes of this for each object parallel. So, when I do this, I probably will fail miserably because the term is not known inside of this context. What choices I have for do this? I just could paste in the function for sure, but we want to pass this function to it, kinda. What we could make use of was the using directive. So when I want to pass something from outside into this script block, for example, I could make some kind of variable like this. Hooray. So, and now I could say something like using applause. I'm not good in typing while everyone is watching. For example, I could make use of something from outside like this. Yeah. So, and if I'm not completely wrong, there should be some kind of. Please, louder. Yeah, that's sorry. It's really, really hard to understand in the back here. So, hey, we do live coding session together. Thank you. A little applause for Jordan. Thank you.
So don't blame me if it goes wrong.
Yeah, no. Because I wouldn't make up a real example yet right now. So, yeah.
So basically what you need to do...
It's a German keyboard. Be aware.
We'll see how we go. All right, what is equal?
Yeah.
There we are. So the first thing that you need to do is you need to get your function itself. Where's braces? Either braces, the
curly one?
Yeah, curly ones. Thank you. So essentially you want to use the function provider.
Yeah.
I should be able to find this colon. Down there. You type in the function name. Yes. And then we have to convert it to a string before we do this because you can't serialize the script block using. Inside this actual function here, you can then do the same thing. The braces again, sorry.
Yeah. Alt GR, and 7.
Alt 7, awesome.
Yeah. And the 8 for the closing one.
Yeah. When you're defining the module, the function, the easiest way is to also using the function provider again. Then we want to go get dash applause. And then alt, I found it. Yes. Shift equals, and then we want to do using.
Basically a text string, yeah.
Yep. I can't remember if I need to actually convert it to a script block, but let's just do it just in case.
I think so, if I remember correctly. But this was what I'm trying to archive right now, but I wouldn't be able to. Yeah.
Because the function is essentially a script block with a name on it.
Shift 8.
Shift, and then we go to the end.
You also can minimize this, so you have a little more space.
I also forgot a dollar at the start of this one here because it's technically through the provider. And then finally, we can do get dash applause. And so the moment of truth, if it actually works.
Yeah, let's find out. But I guess because I've already used this, but I wasn't able to make this on stage. Yeah. So thank you already for that. And yay! Thank you, Jordan. Imagine. So you did applause so perfectly. So any other kind of question that I hopefully able to answer? Yeah, please. Which one of all of these is the fastest? To be honest, the one with the less overhead. And in my experience, it was really run-space factories, because for each object, you have some kind of the pipelining, like I said, with the ASJobs module, you have also some kind of overhead. So run-space factories indeed was, under my experience, the fastest, but we're talking about milliseconds, to be honest. But it was, from my experience, the case. Yeah. Yeah, please. I ignore you the whole time.
Thanks. What's, in your opinion, the best one you should or could use, or is it really depending on the application?
Okay, the question was, what is the one that I suggest to use? To be honest, when I'm on 7.x for each object parallel, it's so easy to just write down, make it work, and you're good to go. When it comes to 5.1, I stick with ASJobs. Sometimes also use thread-jobs because they're a little bit more lightweight, a little bit faster in some circumstances. But like I said, they can blow up your whole process, and you don't want to have this ever happen. So, yeah, you're welcome.
Run spaces makes it much more difficult to understand your own code.
Yeah.
Having done a lot of them.
Yeah, please.
Which technique can we recommend to our junior developers?
Which technique can you recommend for learning all of those?
No, but which one to start with?
Probably jobs, because when you understand what jobs are doing, you saw already, because jobs are integrated into every of those methods. So if you understand this, then go ahead with for each object parallel if you're lucky one of 7.x. Otherwise, really to understand it would be going via like the order I did, to be honest. Yeah. So 2 more minutes. Raising hands, or you all want to have a little break? Or applause. That's don't spoil it. So, okay. Then thank you all for showing up, for paying attention, and also for asking me so many questions. And Jordan, thank you one more time